Boeing has announced the signing of a major $2.7 billion multi-year contract to produce more than 3,000 Patriot Advanced Capability (3) PAC-3 missile seekers through 2030, marking one of the largest long-term agreements in recent U.S. missile defense history. The deal comes at a time of mounting global insecurity and an accelerated demand for cutting-edge air defense systems, as both the United States and its allies move to rebuild their arsenals following extensive operational use in Europe and the Middle East. The new agreement not only ensures a steady supply of key missile components for the next 5 years but also reflects the strategic pivot toward smarter, more autonomous interceptor technologies capable of countering the growing spectrum of aerial threats, from traditional ballistic missiles to next-generation hypersonic weapons. At the center of this contract is the PAC-3 seeker itself, a compact and highly sophisticated Ka-band radar unit housed in the nose of the interceptor. This critical component acts as the missile's eyes and brain, detecting, tracking, and locking onto enemy targets with extreme accuracy. Built by Boeing and paired with Lockheed Martin's hit-to-kill interceptor, the seeker allows the PAC-3 missile to destroy its target through kinetic impact rather than explosive detonation. Once launched, the missile relies on mid-course guidance from ground-based Patriot radars such as the N/MPQ-65 or the new LTAMDS system before switching to its onboard seeker for autonomous terminal homing. This combination of external radar cues and internal precision guidance enables the missile to engage complex, fast-moving threats even in cluttered or electronically contested environments. The advanced design of the PAC-3 MSE missile segment enhancement variant gives it an edge over previous Patriot interceptors. It incorporates a larger dual-pulse solid rocket motor, refined flight control algorithms, and stronger thermal protection, allowing it to sustain maneuverability and energy across longer distances and higher altitudes. These enhancements translate to better performance against a wider variety of targets, including tactical ballistic missiles, advanced cruise missiles, and high-speed aerial platforms. The PAC-3 MSE's ability to sustain extreme G-forces and make rapid mid-flight course corrections ensures it can achieve a direct hit even against evasive or unpredictable threats. In operational terms, this means fewer missiles are needed per engagement, higher kill probabilities, and a greater capacity to handle multiple incoming threats simultaneously. Boeing's expanded production line in Huntsville, Alabama, is being scaled up to meet record output levels, as many as 750 seekers annually by the end of the decade. Since 2000, the company has delivered more than 6,000 PAC-3 seekers, and this latest contract ensures continued growth and stability in the U.S. defense industrial base. Beyond the immediate production boost, the deal represents a strategic move to secure long-term manufacturing capacity in anticipation of future surges in demand. By locking in multi-year commitments, the U.S. Department of Defense and its allies are not only ensuring a steady supply of critical missile components but also mitigating the risks of production bottlenecks that have challenged defense logistics during recent conflicts. The renewed focus on missile seekers also underscores a broader shift in how modern militaries approach air defense. Instead of relying solely on ground-based radar illumination and centralized control, newer systems like the PAC-3 emphasize distributed sensing and autonomous engagement. This decentralization makes defense networks more resilient and flexible in the face of jamming, decoys, and complex saturation attacks. Each missile effectively becomes a smart weapon capable of independent decision-making in the terminal phase, drastically improving reaction times and engagement efficiency. In practical terms, this allows air defense batteries to protect larger areas with fewer assets, enhancing both strategic coverage and cost-effectiveness. Across the Atlantic, Europe is undergoing its own technological transformation in missile seeker design. Airbus, through its involvement in MBDA, is advancing the Aster 30B-1NT modernization program, which integrates a new Ka-band active radar seeker similar in concept to Boeing's design. This European seeker provides higher resolution, better clutter rejection, and enhanced countermeasure resistance. The French and Italian armed forces have conducted successful trials of the upgraded Aster interceptor, confirming its ability to detect and destroy ballistic targets at altitudes exceeding 25 kilometers. These developments feed directly into Europe's SAMP/TNG and naval air defense systems, strengthening the continent's layered missile shield and reinforcing NATO's collective defense posture. Both the PAC-3 and ASTER-30 programs highlight the increasing importance of seeker technology as the defining factor in modern air defense performance. The seeker's ability to operate independently of ground-based radar not only expands engagement envelopes but also enhances survivability and responsiveness. With the new generation of Ka-band seekers, interceptors can maintain lock-on in the face of electronic warfare and countermeasure attempts, while distinguishing between genuine warheads and decoys. This level of precision transforms missile batteries from blunt area defense tools into surgical defensive instruments capable of conserving ammunition and prioritizing the most dangerous threats. The geopolitical backdrop amplifies the urgency behind these technological advances. Ongoing wars in Ukraine and the Middle East, combined with rising tensions in the Indo-Pacific region, have pushed defense industries to their limits. Western militaries have rapidly depleted missile inventories through high operational tempo, while potential adversaries continue to develop faster, stealthier, and more maneuverable weapons. The resulting environment has compressed acquisition timelines and forced a rethink of industrial readiness. Multi-year contracts like Boeing's PAC-3 deals serve not only as procurement programs but as strategic insurance policies, guaranteeing that the defense sector can surge production capacity quickly when needed. Furthermore, the emphasis on seeker technology reflects a shift in doctrine from quantity to quality. As defense budgets face competing pressures, militaries are investing in smarter, more capable interceptors rather than simply increasing stockpile numbers. This evolution is especially relevant as hypersonic weapons begin to enter the operational landscape. Unlike traditional ballistic missiles, hypersonic threats maneuver unpredictably and travel at speeds exceeding Mach 5, making them far more difficult to intercept. The Ka-band radar seeker's ability to track such targets in real time and guide a kinetic interceptor into a direct collision becomes a decisive advantage in the defense equation. Boeing's collaboration with Lockheed Martin and the U.S. Army on the PAC-3 program illustrates how industrial synergy can sustain technological dominance. Each component, from the seeker to the propulsion system and radar integration, contributes to a broader ecosystem of layered defense, where data from multiple sensors and command nodes combine to create a unified defensive network. This network-centric approach is increasingly essential as modern battlefields grow more data-driven and contested. Future enhancements may include AI-assisted targeting, adaptive radar waveforms, and networked interceptors capable of cooperative engagement, where multiple missiles share targeting data in flight to ensure a successful intercept. In essence, the $2.7 billion PAC-3 seeker contract is more than a production agreement, it is a strategic commitment to the next generation of precision defense. It ensures that the United States and its allies maintain not just sufficient missile stocks, but a technological edge that can adapt to evolving threats. The Ka-band seeker symbolizes the fusion of physics, engineering, and digital intelligence that defines modern warfare. With conflicts expanding across multiple theaters and the speed of combat increasing, success increasingly depends on milliseconds, and the ability to detect, decide, and destroy faster than the adversary. Boeing's new chapter in the PAC-3 story confirms that the future of air defense lies not simply in bigger missiles or stronger warheads, but in smarter guidance systems that make every shot count. The seeker, once a small component buried deep inside the missile's nose, has become the defining factor of modern interceptor performance. As production accelerates and global demand continues to rise, these intelligent sensors will shape the battlefield of the future, where the difference between victory and defeat may hinge on a radar pulse, a microprocessor's calculation, and the silent precision of a missile that never misses.